Hi everyone, here we are again. We are looking this time at pyramids specifically. We haven't really talked about them yet. We've talked about prisms and cylinders, but no pyramids. We've seen them a little bit, but not talked about them. So Parker wanted to say hi.
Hi. This is what my mom is using.
Yes, I'm using a stylus to be able to write on the computer. So he has a blue mouth right now. The camera's right up there. There he is. And he's very excited. Oh, he's discovered that he can move the camera around or the video around. Okay, stop. You're gonna make them dizzy. And so we are going to be working with pyramids and looking at what they do and how we come up with the surface area for them. So without much further ado, let's go ahead and get started. We're going to talk a little bit about some vocabulary and we'll get going. All right. Okay, so thinking about a pyramid, here I've got this great little let's see here. So there's a net for a pyramid, and the net, if we think about it, this folds up to create this shape that we recognize as a pyramid. This is a square pyramid because the base of the pyramid, when it's all folded up, is square. And so that's something
pyramids are triangle.
Some pyramids are going to be triangular. Some are going to have hexagons. Some of them are going to have octagons. They can have any kind of base. But in this case, the one that we're most familiar with would be our square pyramids. So a pyramid has a point at the top called an apex, and they have their base. In this case, the base is a square. And then we have what are our lateral faces, and those would be the triangular shapes that meet at the apex. So we can see the net of the pyramid. When it's all folded up, it's got a height on the inside of the pyramid. Ooh, I totally drew that bad. Let me undo that. Let's try that again. There's the height of the pyramid, and we have something called the slant height of the pyramid, which would be the height that goes kind of diagonally down the face of the pyramid. And we use the slant height, we use an L in order to identify the slant height, and you can see that here again, the slant height of the pyramid, because that's the height of the triangular face. That's the height of the actual triangles on the pyramid. And so we're going to be using them in order to find the surface area because we want the part on the surface. Notice the height is not on the surface, it's on the inside, so we don't use the height for the surface area. We want the outside, not the inside. Yes, Parker. You want to point? Parker is going to point something out for you. What are you going to point at?
The next thing.
Oh, the next slide. On the next slide, Parker, can you point out which number is the slant height of the pyramid? Which one goes down the triangle? On this shape right here, which one is the slant height? Which one goes on the triangle side? Oh, he's going to use a different pen. Okay. Wait. Parker, you got to pick quick because I'm not trying to spend all the time. Is that the slant height? Now, is that on the outside of the pyramid? Or is that on the inside of the pyramid?
Ouch.
This is on the inside of the pyramid. Oh. We want the slant height, and that's a common misconception. That's something that a lot of people struggle with. The slant height is going to be the outside dimensions. So we want that value. Can you tell me what part's on the bottom? Very good. So we're going to be using those two values to help us find the surface area of the pyramid. Okay, so here's how we're going to do it. I'm going to erase some of these lines just so that we have some room to write. We're going to try and come up with a method for, hold on, bud. Parker, stop. A method for finding the surface area. So when we think about the surface area, it's all of the faces, everything. So we want the base plus all of the triangles. So I'm going to write triangles like that. So we know that we're assuming here this is a square pyramid. So we know that the base is a square. So we want the area of that. So that would be 16 times 16 or 16 squared. Stop. Plus, we need the area of all of the triangles. So if we wanted the area of this first triangle on the side here, we would assume its base is 16 because it's a square. And we need its height, which is the slant height of the pyramid. So we're going to use that 16 times 17. And it's a triangle, so we have to divide by 2. And what's nice about a pyramid, about a square pyramid, is that all of those triangles in that pyramid all have the same base. So even in the back over here, that back triangle is going to have the same base of 16. And if it's a square pyramid, then they're also all going to have the same, this is getting pretty messy, they're all going to have the same slant height. So really, we just need 2 values for this square pyramid. And we're going to multiply this. So all 4 triangles are going to be the same. So we'll just multiply this by 4. So we're going to kind of calculate this out. So 16 squared is our 256. 16 times 17 divided by 2, I just have this calculated, that's 136. And then there are 4 triangles, so we're going to multiply that 136 times 4. And so that would give me 544. And then I have to add the 256 from the base. And if I add that all together, I should get, wait, what did I do? I did something wrong here. Oh, I see what I did wrong. I used 136 instead of 256 when I did my original calculations on my notes. So I didn't have you guys in class to tell me I was doing something wrong. So that should give us our total surface area of 800 inches squared. And that would be our total surface area of the base plus all 4 triangles. Okay. So that's kind of our method. We got to find our basic formula. And then we're going to be doing this. We're going to find a way if we could have the shortcut like we have from our other, like our prisms, to come up with a method. So if you want to come on back, I'm going to stop this one for now. And then we'll come back and do some other couple of examples real quickly, just so that if you can get it from one, awesome. If you need to come back, come on back, and we'll do these next 2 here in just a minute.